In this video, we'll use the TI-84 calculator to test whether there is a significant linear relationship between two quantitative variables. We'll work through one complete example from the beginning to end. Let's begin. A teacher wants to determine whether the number of hours studied can be used to predict the student's final exam score. And the data are shown in the table. Before starting the hypothesis test, let's identify X and Y. The problem says that hours studied can be used to predict the final exam score. That means the hours studied is the explanatory variable, so it's X. And we want to predict the final exam score. So the final exam score is the response variable, so it's Y. On the calculator, the X values go into L1 and the Y values will go into L2. Step 1, we want to identify the null and the alternative hypotheses. For the null hypothesis, it's always rho equals 0. This means there's no significant linear relationship between hours studied and final exam score. And the alternative hypothesis is rho does not equal 0. This means there is a significant linear relationship between hours studied and the final exam score. Step 2, we need to identify the significance level. Let's go back to the problem. The problem does not give us the significance level, so we'll use 0.05. Step 3, I will need to use the TI-84 calculator to find the test statistic and the p-value. First, enter the data, press Stat, choose Edit, and press Enter. Enter the hours studied into L1. Enter the exam scores into L2. Make sure the values in L1 and L2 are paired correctly. Next, press Stat again. Move to Test. Scroll down to find linear regression t-test. This one. And press Enter. For X list, enter L1 because I store my X values in L1. For Y list, enter L2 because I store my Y values in L2. Again, if you store your values in different lists, make sure you replace it. Leave frequency as 1. For the alternative hypotheses, select not equal to. Highlight Calculate and press Enter. The calculator reports the test statistics T, p-value, and also R. Now, if you use this linear regression t-test to find the regression equation, notice that the equation format is different. It's now y equals a plus bx. So a is your y-intercept and b is your slope. This is the result that I got from the calculator. This t value is the test statistic. And I want to round it to 4 decimal places. So my test statistic is 29.1433. And this number is my p-value. P-value is 8.25265,475 times 10 to the negative 6. And when you multiply a decimal by 10 to the negative 6, means you will move the decimal point to the left 6 places. So I have 0.0000825265475. And I want to round this number to 4 decimal places. So p-value is approximately 0. Step 4, I need to make the decision whether I reject HO or do not reject HO. To make the decision, I compare the p-value with alpha. Since 0 is less than 0.05, so p-value is less than alpha, so I will reject HO. Always remember to justify your answer. And step 5, we need to state the conclusion using the problem's context. Now, what does it mean when we reject HO? Go back to step 1. This is HO, this is HA. This means there's no linear relationship. This means there is a linear relationship. Now, we reject HO. That means we do not support HO. So we will support HA. So yes, there is good enough evidence to conclude that there is a linear relationship between the two variables. Therefore, the number of hours studied can be used to predict a student's final exam score.